Hi everyone, welcome back to school in the start of semester 2. We're going to start off the semester in chapter 6 and we're going to look at solving linear systems by graphing. So far we've learned how to solve a lot of things. We've solved equations and inequalities and we've found solutions of linear equations, but now this new thing we're doing is called linear systems. Now, hopefully this word linear, that should be very familiar to us. We looked at linear equations, which we knew when we graphed them would be lines, straight lines. So now we're going to be looking not just at one linear equation, but two or more. And that's really what we're talking about here when we talk about a linear system. It's a set of two or more equations with the same variables. So for example, if you look over here, we have the equation x plus 2y equals 7. Here my variables are x and y. If I look at my second equation, 3x minus 2y equals 5, you'll see I have the same variables x and y. So that makes up a linear system. It's just two or more linear equations, which are things we've already worked with before in semester 1. So in this chapter, we're going to be looking for solutions of linear systems. And for linear systems, the solution is an ordered pair of numbers that satisfies both equations. So in this chapter, our solutions are going to look like ordered pairs, and we know that those have an x and a y coordinate. So the first thing we need to be able to do is to tell whether an ordered pair is or is not a solution. So you can see here they've given us an ordered pair and they've given us two linear equations. And we have to see if that solution makes both of these equations true. So here's what we're going to do. We know in our equation, in our ordered pair, we have an x and a y coordinate. The x is always first and the y is always second. So here's what we're going to do. I'm just going to call this equation 1 here. So what we're going to do is I'm going to start with the first one. Wherever I see an x, I'm going to substitute the x coordinate. So I have 4. Then I have plus 2 times, now instead of y, I'm going to substitute the y coordinate, which is 1, and I need to check, is that equal to 6? Right now that's kind of a question mark. So we're going to evaluate the left side here. If I were to do 4 plus 2 times 1, if I put that in my calculator, I'm going to get 6 on the left side, which is equal to 6. So at this point, all I know is that the ordered pair is a solution of the first equation. However, before I can say it's a solution of the system, I have to plug it into my second equation and see if it's also true. So now in equation 2, I have 3 times, instead of x, I'm going to plug in my x coordinate, which is 4. Then I have plus y, well my y coordinate is 1. And I need to check, is that equal to 11? Right, that's our question here. So now in this case, if I evaluate the left-hand side, I have 3 times 4 is 12, plus 1 is 13. 13 is not equal to 11. So since this ordered pair is not a solution of both equations, we say it is not a solution of the system. It has to work for both. Right, we'll just try one more example. So the same idea here, right? If it's a solution, it has to make both equations true. So I have my x and y coordinate. First, we're going to test it with equation 1. So I have 5 times, in this case, my x is negative 2. Then I have minus 2 times, well my y coordinate is 1, and I'm checking if that equals negative 12. So if I evaluate this, I have 5 times negative 2 is negative 10 minus 2, That gives me a negative 12. And again, here's where I would recommend just type this whole left side into your calculator and let your calculator do the work for you. So far we're looking good. The ordered pair is a solution of my first equation, so let's check out the second one. So for number 2, I guess I should have labeled this as my check for number 1. So for number 2, I have x. Well, my x coordinate is negative 2. Then I have plus 3 times my y coordinate, which is 1. And I want to check, is that equal to 1? So again, I'm going to evaluate the left side. I have a negative 2 plus a positive 3. That's going to give me a 1, which is equal to 1. So since this ordered pair is a solution of both equations, in this case, that ordered pair, that point, is a solution of the linear system. So what we've learned how to do so far is to tell if a given point is a solution. However, what we're going to have to be able to do now is actually find the point that is the solution of a system. So they're not going to give us a point anymore. In these next set of problems, we're going to be given a graph, and we have to now, sorry about all my jumping around, we have to now find the point that is the solution. So here's how we're going to do that. You see we have two linear equations here. We're going to graph both equations and we're going to find where the lines intersect. And remember, cross is just another word for intersect. So we're going to find where the lines intersect, and that point is going to be the solution of the system. So for this part, it's going to be important that we remember how to graph linear equations. And remember, we're looking here, these equations are in the form, hopefully we all remember, y equals mx plus b. The b is our y-intercept, and it's where we begin. The m is our slope, and it tells us how to move to locate another point. So let's start with our first equation here. Y equals negative 1/2 x plus 2. So for this equation, my b value is a positive 2. So on the y-axis, I'm going to find positive 2. My slope is negative 1/2, which tells me I'm going to go down 1 and to the right 2. Now, when we're graphing to find these solutions, it is going to be very important that you have nice straight lines. If you don't, it's possible you won't be able to easily identify the point where these lines intersect. So please use some kind of straight edge, whether it's your ID or your calculator case. I've got a little ruler here, and I'm going to be as precise as possible here, going through those 2 points, and there's my line. So far I've got one line. I'm going to graph my second line, and hopefully I'll be able to tell pretty easily where the two lines intersect. So my second equation here is y equals 3/2 x minus 2. So in this case, my b value is a negative 2. So on the y-axis, I'm going to go down 2. Now my slope is 3/2, so I'm going to go up 3. And run 2. And in this case, it works out really nicely. I can already tell where that solution is. So if I connect my 2 points here, now I can see that they cross at this point here. That's where my lines intersect. So if I'm looking for an ordered pair from the origin, I'm going to go right 2 and up 1. So my solution is 2, 1. Now, you guys know by now that I'm pretty big on checking. If I think this is my solution, I want to check and actually find out if I'm right or not. So I can check using the same skills that we did up here. I know that if this is really a solution, then this ordered pair should make both of these equations true. So let's go ahead and test it out. And I'm going to show this work to the right side. I'm going to put a check mark to show that I'm checking. So in my first equation, I have y. Well, I think that my y value is 1 equals, let's see, I have -1/2 times x, which I think is 2, and then plus 2. So now I could use my calculator to evaluate the right side, and I have 1 is equal, well, -1/2 times 2 is a -1, plus 2 is a +1. So far it looks good. If I plug it into my second equation, I have y. Again, I think my y value is 1, is equal to 3/2 times my x value, which is 2, and then -2. So I get 1 is equal to, well, let's see, if I do this, 3/2 times 2 gives me a +3, -2 is 1. Since both of these came out, I know that my ordered pair is correct. So that's what we're talking about when we're finding these solutions by graphing. You're literally just graphing both of the lines and then finding where those lines cross. Now, if you flip ahead to the next page, you can see that this gets a little more difficult. On the next page, you can see that these aren't in slope-intercept form anymore, so we're going to have to rearrange first. And those are the problems that we'll start with at the beginning of class tomorrow, just so we make sure everyone remembers those steps. All right, that is it for today then. I'll see you back in class. Thanks.